Okay, all right, so this particular week, you're going to be given the chance again to select a problem from the projects and to be able to go over that. And again, because we just have 6 people, or actually 5. Yes, sir?
Can I take a picture of that real quick?
If you'd like, yeah.
Just so I can have it on my phone second.
Well, it'll be on the teacher page this afternoon. I may actually be there right now. But anyway, so there's these numbers, all right, and the presentation is going to be the week of December 1st, which is whatever that Tuesday is, the 1st or the 2nd. And the reason for that is I don't want to come back from Thanksgiving and immediately have that project. All right.
Wait, when is Thanksgiving again?
Is it 25th? 26th, right.
Okay.
Next week you'll get a double assignment. It'll be assignment for the week and also for the next week.
So we won't have anything the week of Thanksgiving.
You will have something the week of Thanksgiving, but you can do it ahead of time if you want.
We won't meet here.
We will not meet the week of Thanksgiving. And then the week that we come back, like I can show you that. Let me pull that up on my... Okay, so, all right, next week I'm going to give a double assignment. All right, and if you can see here, that'll be for the 17th and the 24th. Thanksgiving is the 26th. Then when we come back, we're going to present that following week, all right? So you basically have 3 weeks. There's only one more week after that. So we've got to get the presentation in. Yes, sir.
So, just out of curiosity, Christmas break starts the 8th?
No.
Or does it start the 15th?
It starts after the 15th.
After the 15th?
Yeah.
So will this geometry class just be over, or will we have stuff?
No, it's over.
It's over?
It's over,
Okay.
yeah.
I know we're not meeting that semester, but I didn't know if we were going to have some leading over into this.
No, I don't think so. I don't think so.
We won't have anything, because we don't have any of the high school classes.
Yes, we do.
What?
No, not the high school.
Not high school.
Yeah. Now what you've got to remember is that the exit exam for this class is the prerequisites for the Math 133. So all these things that you're supposed to be doing, the college algebra prerequisites that you're supposed to be working on, right? You're going to have a test over that, and you have to pass that test in order to be ready for the college algebra class. All right, so that's the reason for that, and that's it. Yes.
You're helping with sending them out. I'm looking on a thumb drive and I don't see any prerequisites. Like, I get them from your emails. But are they supposed to be on our thumb drive?
I don't have any idea. I don't know, but I'm making sure. I'm trying to make sure that you have them. There's only 5 or 6 each time, and I think only once in these however many weeks have I had anybody even ask about those.
Okay.
So I'm assuming that there are things that you're reminding yourself of, and when it comes the cumulative part, and you'll be able to get that. Okay, so I thought that in the Google Drive for geometry there was a list of prerequisites that showed you the pages. All right, so double check.
In the books, at the end of every chapter, there are college prerequisites.
All right, okay, no, that's in our geometry book. But for the Math 133 class, there was a list of prerequisites that and it's in my Google Drive for geometry, so I'm assuming that it's part of the Google Drive.
Okay,
but I really haven't looked at the jump drive to see what was given on jump drive. All right, sorry. Okay, now, all right, so that's coming up, and so again, it's nice that you'll have next week. You'll have the 2 assignments that will finish chapter 10, and then you'll also have the geometry one. Now, the instructions for the coming project say that you're supposed to use a real-world example. as part of your discussion, right? And so this one should be very solid mathematically based on this particular skill, because a lot of what we're doing right now is proportions, right? And following those things. So the discussion of it should be much more detailed, and where you're actually teaching how to get that problem done. That's what I'm going to be looking at. Okay, so that's that part of it. Okay, now I want to go back to the trigonometry, sorry. Go back to the trigonometry section, and I wish that I had the handout, so I'm going to try to do it without. Okay, the first section, 1 through 6 on this handout, says find the following trig value. Yes, sir. All right. Can you wait just a little bit until I get this part? So the first thing says the sine of 12 degrees. Okay. Now, there's two things that you have to be concerned about. Number one is that you are in degrees and not radians on your calculator. Now, right now, you don't have a reason to change. You're supposed to have that this week. What happened?
We were supposed to have it next week, but then they moved the movie date to Thursday, so,
okay.
Yeah.
All right, so in mode, if you'll turn the gear, Chase, you've already had this, you go ahead and go. All right. In mode, you got to be down on the third one. Make sure that it says degrees and not radians in the bottom. All right. If you need to change it, you just get on the part that's flashing, and when you press enter. But you got to be in degrees, because degrees is talking about the angle. Radians is related to the distance all the way around. Now, an entire circle is 2 pi radians. Okay, so 2 times pi is basically 3.1416 times 2, which is 6.28, 6.29, right? So the distance all the way around a circle with a radius of 1 will be 6.28 radians. So halfway around a circle is 1 pi, because the circumference of a circle is 2 pi r. Well, if r is 1, the circumference of a circle is 2 pi. That makes sense, right? Okay, so therefore, with a degree, or with a radius of 1, the radian measurement is the number of pi's that you get, however far around the circle you go. And then we're going to talk about that in a little bit more detail. But for what we're doing, if you're on radians instead of degrees, then your calculator is going to lie to you. Okay? So, in order to be able to do any type of trigonometry thing, you press the name and then you punch in the degrees. All right? So, on the handout that I gave you, how would you find sine of 12?
Sine 12.
You press sine and then punch 12, press enter, and it's going to fill up the screen, and you usually give it to 4 decimal places. All right, so let's do that. What is the sine of 12?
0.2079.
All right, let's here, clear. Sine of 12, all right, is 0.2079. So the sine of 12 is 0.2079, and that is an estimate because it's not exact. If I needed exact, I would just write sine of 12. Right now, if you were going to use this number, you can store it to x, and it'll store the exact number instead of having to round it and cut it off at the thousands, or in this case at the 10,000th place. Right? So you can store it to x, and then it'll keep the actual number there. Okay, so if it has sine or cosine or tangent, right now, when you get into the higher levels of trigonometry, they flip this sign. And when you flip this sign, 1 over the sine is called the cosecant. 1 over the cosine is called the secant, and 1 over the tangent is called the cotangent. Right? In order to be able to get that, you'd have to flip this fraction. Okay? How do you flip that fraction? You raise it to the -1 power. So take that number and raise it to the -1. And you find that it is 4.8097. 4.8097. So if you're going to have 1 over the sine, which is equal to the secant, and SEC is the secant, so the secant of 12 degrees is equal to 4.8097. So those work. There's a co in each. So there's sine and cosine, and then there's secant. Oh wait, this should be the cosecant, sorry. The cosecant, which is CSC, and then the secant goes with cosine. So there's one co on the flip, and there's one non-co on the flip. Right now. So now the next one asks you to find the cosine, and it gives us a triangle. And so the triangle has A, B, and C, and it has 21, 29, and 20. Okay, now, how would we know whether or not this was actually a right triangle?
Because that's a line.
A squared plus B squared has to equal C squared. That, Pythagorean theorem. Okay, now, the sine of that angle, the sine leg is across the triangle from it. And when I teach trig functions, whatever the angle is, and this one says the cosine of C, all right? This is the sine leg, and this is the cosine leg. And the fraction is cosine leg over hypotenuse. So the cosine of C will be 20 over 29. In that case, you just leave it there. That is the fraction. That is the fraction. All right, now I'm going to add something. If you needed to know what is the angle C equals, C degrees equal, you use cosine minus 1 of 20 over 29. All right, and so you second cosine, and what it does is it says, give me the angle that will produce the same fraction as that cosine.
So if we just put cosine 20 over 29.
If you put cosine 20 over 29, you're going to get the cosine of an angle that is less than 1 degree, because that's what 20 divided by 29 is. See, this says the fraction for the cosine is this value. Okay, so let's do that. What is 20 divided by 29? All right, it is 0.6896551. All right, that's what happens when you put 20 divided by 29. Okay, now I want to know what degree angle is that? So let's do this. Clear your calculator and press 20 divided by 29. Right? That's the value. That is what we're supposed to find. So now we're going to go second cosine, and you should see cosine with a -1. See it? In your calculator? Second cosine, and now we're going to put 20 divided by 29. When I press enter, it tells me that it is 46.397 degrees. That is the degree measurement of angle C. All right, how do we know that? All right. Now, without clearing, press cosine, of 46.397 and press enter, and you get that 0.68 that we had in the first one.
Yeah,
Did you not?
I did.
Okay, here's why. Here's why. This is the number of degrees that produces this fraction. That fraction number with that number of degrees is hardwired in the calculator, right? So what we did was we told the calculator with the second cosine, look down your list of cosine numbers and find the angle that has a measurement of 0.689. And so the calculator looked at it and it said the closest you can get is use that angle. That's second cosine.
So that 0.6896551, that is the percent.
Is the fraction that you get when you divide the leg by the hypotenuse, because the hypotenuse is longer, right? So whenever you set up a fraction with one of these legs over the hypotenuse, you're going to get less than 1.
That's also, isn't that also the percentage from
No, don't think about percentage.
Okay.
But although you could, but it's a fraction.
Okay.
It's just a fraction. Okay, now, so what would the sine of angle C be? The sine of angle C is the sine leg, which in this case is what?
21.
21 over 29. Okay?
And what is that?
That's a different number, right? But here's what I want you to do first. Put sine of 46.397. Sine of 46.397, because we said that was the degrees.
0.72.
0.72. Now take 21 divided by 29, see what you get.
Same thing.
Same thing, only it down, because we cut it off, down into tens of thousands it gets off. All right, so all sine, cosine, and tangent are fraction relationships between the legs or the sides of the triangle. Okay? They're fraction relationships, and the values are set up in the calculator because if like for instance, the difference between this particular triangle that has a hypotenuse of 29 and a right triangle of the same angles with a hypotenuse of 1 is that there's a multiplier difference, because whatever this side is the hypotenuse times some constant, but because they're all proportional, this is the cosine leg times a constant, and what happens to the constants? They will cancel out. Right?
So
you see that? I turned that on, didn't I? Yeah.
yes.
Okay. All right. So now this one here, this is something I want you to see. Where is the hypotenuse supposed to be for sine and cosine? The hypotenuse is supposed to be where? On the bottom of the fraction. Right? So when I set it up this way, these things will still cancel, but this, if this is the cosine leg, if the hypotenuse is on the top, that's called the secant, which is SEC. That's the secant of angle C. Right? And all that is the flip of the fraction. All right, now, so let's look at problem on this handout. Let's look at problem 8. All right, and we're going to talk, it says the cosine of A. So from the letter A, send an arrow down through the triangle toward the side. All right, on your handout, send an arrow from A down through the triangle.
On which number?
Number 8.
Number 8. From A down through the triangle?
Down through the triangle.
Where?
The arrow that you are using is pointing to the sine leg.
Oh, that.
Okay? So I'm gonna do it using this one. So that right there is the sine leg. And according to this is 30. 16, and this is 34. Okay, now, the sine of angle A is equal to what fraction?
Thirty over 34.
30 over 34.
So is that the angle of A?
No, that is the fraction based on what angle is there. I don't know the angle yet. Now, suppose I change this and said this. -7 degrees. What is the sine of 27? Now, that's calculator work. Sine of 27. 0.4539. Okay, so when the hypotenuse is 1 and the angle at A is 27 degrees and it's a right triangle, that makes that angle 63. The calculator knows those two angles. Therefore, this triangle is similar to another triangle whose hypotenuse is 25. Now, what will I multiply this triangle by to get 25?
25.
Therefore, I multiply this fraction times
25.
25, and I'll have that length. Yes.
So you have, like, go back to the,
Yeah.
not the triangles you just drew, but the triangle over.
Okay.
That one. How would you get the angle of A?
All right.
Again.
To be able to get the angle of A, you use second and then the sine. So
Second sine.
All right. So second sine will be the sine inverse, and what's in here is the fraction that you know. In this case,
would be 60.
in this case, it would be 30 over 34. All right, and when you put that in the calculator, it tells you the value of that angle. And what did you say it is?
61.9275.
So this is a 61.9. Let's say 62 degrees. That's 62 degrees, and how much is this? Well, it takes 8 to make 70, and then 2 more, so that angle C is 28 degrees. Based on the sides of this triangle. Right? And so inside of here is a right triangle that has a 1 here, and that decimal value is going right there. This triangle is 34 times larger than the one that's in the book, but when you take 34 times the sine leg, and you have 34 times the hypotenuse, those cancel out, and that fraction is exactly the same no matter how many times you have to change the size of it because they are similar triangles. All right, does that help a little bit? Okay, now, all right, so now what I want to try to do is move down a little bit. All right, turn over on the back side. Turn over on the back side. Now, the back side is talking about trig equations. And what we're going to end up doing is having a value from the calculator, and we're going to have a fraction that it equals. Okay? Now, so, problem 13, I'm going to copy the problem. Can't use that because that pen is out of ink. All right, problem 13 says this is x, this is the right angle, this is 17, and this is 38 degrees. Okay, now, with my arrow, all right, do I have the two sides necessary to make a trig function? I have a sine and I have the hypotenuse, right?
Well, you could.
All right, so therefore, the sine of 38 degrees is equal to 17 divided by x, right? Now, sine of 38 degrees is just a decimal number. Right now, let's just stop and think. Okay, so now this is a number, that's a number, and that's a variable. So now I'm just going to use some simple algebra. In fact, I'm going to use cross multiplication. Right? The x comes up here, and then I divide, and so I have 17 divided by the sine of 38 degrees. Now, sine of 38 degrees is just a decimal in the calculator. So, put 17 divided by sine of 38.
27.6125.
All right, so that means that the side that's missing is 27.61 centimeters, or whatever that is, because this says x is equal to 27.612577. All right, but how did you get that value? You use the decimal that's in the calculator for this fraction, and you compared it to that using algebra. The only way that you'll get the number is if you take 17 and divide it by this. You'll get the sine of 38. Now, I didn't look to see what the sine of 38 was. I could have. But all I wanted to do was to get a relationship between the sine fraction that I get off of this triangle and the value for the sine fraction that's in the calculator. Okay, so let's go to 14. Let's do another one. All right, now, problem 14, all I do is change the directions of the triangle. All right, so 14 has the right angle there. They say that this is 52 degrees, that this side is x, and that this side is 15. Now, if I go from the 52 degrees and go out here, that's the sine leg. Do I have a value on the sine leg? Yes or no?
No.
Therefore, I can't use sine. What am I going to have to use? I have to use cosine. So therefore, the cosine of how many degrees? 52 is equal to the cosine leg, which is x, over the hypotenuse, which is 15. All right, how do you solve that for x? You do half cross multiplying and say what?
X is equal to 15 over.
No, not over. Now it's just 15 times.
Oh, yeah.
Right? So 15 times square root of 52. All right, it's got to be less than 15 because it's a decimal. All right,
Y square root.
Huh?
Y square root.
It's not, I didn't say, did I say square root? I'm sorry, 15 times the cosine. I was doing square root in the other class. Okay, sorry.
Okay.
So 15 times the cosine of 52.
And that is the length of...
That is the length of x.
Of x.
Yes.
Oh, yeah, and that would be 9.23, whatever.
All right, 9.23. Now, how do you find the other one? You can call this y, right? If I call that y, then the sine of 52 degrees is y over 15. Right?
Same thing.
Which right, only your sine. So what is 15 times the sine of 52?
11.82.
11.82. Now, let's do a squared plus b squared and see that equals c squared. 15 times 15 is 225. So what is 9.23 squared plus 11.82 squared? It should be 220 something. Okay, so you're not doing this. Okay. Did you get it?
15.
Oh, you took the square root of it too, yeah. I was going to say, because this is 15 squared, 225 has to equal 9.23 squared plus 11.82 squared within, it should be 220 something because we lost a little bit. So put 9.23 squared plus 11.82 squared, and how close to 225 are you?
22.4.
Which is reasonable within rounding. Right? Okay. All right, so, but in the trig functions, you're trying to be able to set up the fractions with the legs and compare it to the values that are in the calculator. If you are trying to find the angle, because you're not given the angle, then you use second whatever, either second sine, second cosine, or second tangent to be able to find those, okay? All right, now, that is part of the last chapter that was kind of weak in this class, so I hope that helps. Okay, now, all right, so we've got project 3. Okay, now page 368, we're going to look at the self-test for this chapter 10. All right, two students, A and B, have the same build, but A is 5 feet tall and B is 6 feet tall. If A weighs 225 pounds, guess how much B weighs? Okay, now this is a test problem, self-test problem. All right, if the information says that A and B are proportional, then what fraction? Then what fraction can you set up?
5 divided by 125.
Well, wait a minute.
Wait, no.
First of all, tell me about A and B. A is to B as 5 is to 6 as A of 125 as 125 is to X. All right, how do you solve for X? Cross multiply, the 6 comes to the top, and the X comes to the top, then you have to get rid of the 5. So you have 125 times 6 divided by 5, right? You do the cross multiply, and the X will end up here, but then you have to divide by 5, so you have 125 times 6 divided by 5 is the value of X for A. What about B? All right, A's clothes cost $10. Guess how much B's clothes cost?
So A is to B.
So we still have 5 over 6. Now A is 10, and we got to find B. So it looks like we have 60 divided by 5, whatever that is.
12.
Okay. All right, now, what happens on this? All right, suppose P and Q are similar polygons. The ratio of the length of P to the corresponding Q is 1/3. So which one's bigger?
P.
All right, P is to Q as 1 is to 3.
Oh, so Q's bigger.
Yeah. Yeah, because see, this is 1 to 3. Right?
What's the ratio? P.
All right, so Q is three times bigger. All right, what's the ratio of the perimeter? Okay, now this gets back to what we talked about last week. When you are using area, you have 2 different lengths multiplied together, right? So if you're talking about the area, you're going to have 1/3 times 1/3. If you're talking about volume, you're going to have 3 1/3. That's 1 over 27. But the length, the perimeter, is just going to be the same. So the perimeter relationship is 1 to 3. Okay? The ratio of the area is
1 over 27.
no, not area, because area is length times width.
Oh, 1 over 9.
This is 1 over 9.
So volume would be 1 over 27.
Yeah, volume would be 1 over 27. Okay, now, if the ratio had been 1/2, then what's the ratio of the areas? If the ratio of the lengths is 1/2?
1/4.
1/4 is the area, and the volume will be 1 over 8. Okay? All right, now, so that's those two, okay? Now let's look at these, if I can get it up here. All right, so there's two diagrams. All right, suppose that PQR is twice the area. All right, what will PQ divided by AB be?
PQ over AB is going to be 2 over 1.
All right, except for that 2 is not, remember when it was, when the ratio was 1 to 2, the area was 1 over 4. So 4, the square root of 4 was what?
Oh, it has twice the area.
Twice the area. So you have to take the square root of that to get the original length. So it ends up being square root of 2. All right, think of it this way. All right, we'll go to one that we just did. If the area is 1 over 4 and the volume is 1 over 8, then the length
Is 1 over 2.
is 1 over the square root of 4, and the length is either 1 over the cube root of 8. The square root of 4 is 2, and the cube root of 8 is 2. All right? So what they said here was that this area is 2 times this. So what does that mean for the length?
That is 1 over the square root of 2.
So it would be square root of 2. Right, this is
Well,
square root
it
of
would
1.
be square root of 2 over 1.
Yes.
So just make it
Yes,
square root of 2.
square root of 2, yeah. Yeah, so the multiplier, if you multiply the smaller one times the square root of 2, you'll get the larger length. And so square root of 2 times square root of 2 is an area of 2. And then they could do the same thing with a volume if they want. Okay? Now, the ratio of the area of this to this. Okay, now, okay, what they didn't give you here, if you remember, these 3 triangles are all similar. Okay, so this is the hypotenuse of one triangle, this is the hypotenuse of the other triangle. The small ones, right? Okay, so the ratio of the area of A, D, C, and of C, B, D. So the ratio, so what's the hypotenuse of the larger one?
3 over.
The larger one hypotenuse is 4, and the other hypotenuse is 3 when I have the big one in relation to the small one.
Is that the way you normally would put it? Is the big one?
It doesn't matter. I could have flipped the whole thing over. If I put the small one on the top, I'd have 3/4. So I take 3/4 of the big one, I get the small one. In this case, I multiply the small one by 4 over 3, 1 1/3, and I get the bigger. Okay, so what's the area? What do I do with those 2 numbers for area?
Square.
Square them. Everybody say square.
So that's 9.
Square them. So when I square this, I get
16 over 9.
16 over 9. Suppose it was volume.
Cube.
Cubed, and therefore, what is 4 cubed?
64 over 27.
64 over 27. All right, you see how those relate? Once you understand those relationships, that linear is to the first power, area is to the second power, and volume is to the third power. Then it's just a matter of, okay. All right. Now, okay, here's some trig problems. Okay, now, it says, find the angle of x. Okay, so then the question is, does this make a right triangle? What is 3
A
squared?
squared minus, if
What
A
is-
squared plus B squared equals the square root of.
Yeah, okay, so let's see if 3 squared plus 5 squared equals 34.
It equals 34.
Calculate. 3 squared plus 5 squared. If it equals 34, then
The
the
square root of that would be the hypotenuse.
That's right.
It's not-
Right,
it's
okay.
not-
So a squared plus b squared equals c squared. That means that is a right angle,
Right.
90 degrees. Okay, now here, this is a right triangle. All right?
They gave us the link.
Okay, now if you look at this is 2x and this is 2. Right? So if I use a squared, I have 4x squared.
Where's the 4?
2x.
Okay.
Right? 4x squared equals 4 plus this distance here, which I'm going to call y squared. What about this small triangle? This small triangle says 5 is equal to 4, which is 2 squared, plus this, which I'm going to call z, plus z squared. All right, now let's solve the z first. All right, what's the value of z have to be?
The value of z has to be more than.
No, it has to be what? Z squared plus 4 has to equal 5.
Yeah.
So what does z have to be?
less than
Oh my goodness, folks. If I had 4 plus what is 5?
It'd be
1. So what will z be if z squared is 1? It's 1, right? Okay, so that makes this value 1. Therefore, this is x plus 1 squared. All right, and that is a calculator problem.
Wouldn't that be 4x squared equals 4 plus x squared plus 1?
All right, that's just that side, because now this is a 1. So this whole distance is x plus 1. So now that's a, all right, let me see. Let me go back. Let's get this one up in a different way. Let's look at, so I have 4x squared equals 4, which is this, and then x plus 1 squared is x squared plus 2x plus 1. To solve that, we have to get x equal to, we have to get it equal to 0, right? So I'm going to bring this over here, and I'm going to get 3x squared. I'm going to bring this over here, minus 2x, and 4 plus 1 is plus 5. I'm sorry, minus 5.
Would you need the 3x squared?
I brought this x over to the other side.
Okay.
All right, and then this is 2x when I bring it over to the other side. This is 5, so I want to bring it over here. So now I have the product of 15 that adds up to -2. That is x and 3x. And then that is going to be 1 here and a 5 here. Now I have 3x minus 5x, which is -2. So in this case, x can equal -1, or x can equal a positive 5 over 3. Can the distance be -1?
No.
No. Therefore the x is 5/3. Right, now that is a geometry problem that uses all of your algebra
Wait,
2
where do you
skills.
5/3 again?
This equals 0. Add 5 divided by 3, 5/3. See, this equals 0. That's the original.
Okay.
So when I factored it, x can't be -1. It has to be a distance. So that one's wrong. This one will be 5 divided by 3. So x is 5/3 is the only solution that works. All right, now this one, next one, in C, we've already had some of that. Okay, this is a 30-degree angle. That means this is half of this. If this is x over 2. Right? Now, in a 30, 60, 90, this one right here is x over 2 times the square root of 3. Remember? right? So because that's how this works. Is that the hypotenuse is twice as big, and then the 60 side is square root of 3 times the 30 side. So now I've got 4 equals x square root of 3 divided by 2. Okay, how do we solve that? Clear the fraction. Clear the fraction and get what? 8 here, right? That takes care of this. And how do I get rid of square root of 3? Divide. And then I have to rationalize the fraction. And so I get 8 square root of 3 over 3. Now, unless you know the 30, 60, 90 right triangle thing, there's no way to do that. You have to know the 30, 60, 90 right triangle relationships in order to be able to know how to get 4 equals that blue thing. Now, this one is a little bit different because this is an isosceles triangle, right? And so, what do we know about the relationship here? We know that this line is a bisector. So those two sides are equal. Now, oh, this isosceles right. I didn't see that. There's a, so that makes this a 45-degree angle. Okay, now here's something that you could do. If I know that that's a 45-degree angle, can I use a trig function?
Yes.
All right, what trig function can I use if that's 45 degrees, then the x is what leg? So I can use the sine of 45 degrees is equal to x over 2. So what do you put in the calculator? 2 times sine of 45. All right. The other way that you do that, if this is x, right? This is x times the square root of 2. So 2 is equal to x times the square root of 2. What is square root of 2? And so x divided by the square root of 2. Okay, so let's look at this. Let's put 2 times the sine of 45 in your calculator. 2 times the sine of 45 equals
1.41.
Right, okay. And then 2 times the sine of 45? All right, now put 2 divided by the square root of 2 in your calculator.
Same thing.
Same number. Okay, so you could have got it to trig because we know that this was a isosceles right triangle, so each angle is 45 degrees. And then, or we could have used it using a trig function, or we could use the isosceles right angle. Right now, last one is pretty easy. I'm not going to do that one. Okay, this one over here, you have the shortcut of this, x squared is equal to 5 times 12 when you cross multiply. Because we have 5 is to x is to 5 as 12 is to x. In these two triangles. See, what's the hypotenuse in this triangle? Is a 5 and x is a leg. Then in this triangle, you have x as a leg and 12 as a 5. So you end up with that relationship. So square root of 60. Is that okay? All right, the altitude of an equilateral triangle is 3. What's the area? Okay, so here's an equilateral triangle. If this is 3, okay, this is the 30 degree, and this is the 60 degree. So if this is x, then this is x times the square root of 3. So x times the square root of 3 equals 3. Then that height of 3 times this base. Becomes that triangle. All right, 30, 60, 90 right triangle is an area of 6 times square root of 3. All right, if you have a 30, 60, 90 right, we have the height, and for this particular triangle, this distance here, x, is half of this distance here, so this is 2x. And this part here is x times square root of 3. And then this one, this is 2x. I'm sorry, wait a minute. This is 60. So if this is the 60, then this is x over square root of 3. And you have to add that together to get the base. And that equals 2 times square root of 3. And it's going to be nice because when you distribute, square root of 3 is the case. That's how that works. All right, now, all of this is part of the section that you just got your homework on. All right, so. All right, the length of the hypotenuse of an isosceles right triangle of area this inches. Okay, what is the length of the hypotenuse of an isosceles right? So what's an isosceles right triangle?